Hello. In this lesson, we're going to continue the homework guide. In this week, we actually have quite a bit of homework, which applies the trigonometry that we have learned in various applications. And we've gone through 1, 2, 3, 4, right? We've done some examples in 1, 2, 3, 4. If you have any questions, please send them my way. And in this lesson, we're going to talk about how to work these expressions, how to work these out, okay? This will be a great exercise for us to get oriented, to review the domain range of all these different functions. Especially, you can see there are hardly any special values. We have a special value here, which is sine half. I'm going to explain these notations. Okay, I'm going to explain this notation. Here we do have some special values, but very few. Most of the others are not special values. So this will help you to review what is in the, what is in the other, what in the previous week, so that we have learned, right? So we get to apply them. So let's get started. Okay, the first one. Okay, the first one we have here is sine of arc sine 3/5. Sine of arc sine of 3/5. Okay, so I'm going to share screen with you on the other page. Okay, so to find exact value, okay, so the first one we have here is sine of arc cosine of 3/5. 3/5. Okay, and we haven't been using the other notation in the more modern textbooks. Arc cosine is often written as cosine, inverse. And when you see cosine inverse notation like this, I want you to read it as arc cosine. Okay, so this guy is the same as arc cosine. Okay, it's not the inverse of cosine, is the arc cosine we've been talking about. Okay, so I put AKA here. Okay, now, how do we resolve a question like this? We certainly don't have any shortcut, right? We had shortcut which we have sine, arc sine, or they're cosine, arc cosine. We have that kind of story. How about in these cases, right? How do we find the exact value in particular? Okay, so in this case, we really need to know the domain and range of arc cosine. So first we need to examine the value right next to arc cosine. Is it in the domain of arc cosine? What is the domain? What is the range for arc cosine? That's what we need to understand. Okay, you can pause now to investigate that, right? So arc cosine, right? We know it's a function. It takes a ratio, right? And the ratio has to be between, it has to be between -1 to +1. Okay, so the ratio, which is in the domain of arc cosine, has to be between -1 to +1. And after the application of the function, the range is going to be angles that are going to be in 0 to pi. 0 to pi, okay? And of course, in this case, it's not a special angle, right? We just go straight to ARD. We're gonna go straight to ARD. So first, I'm going to draw a rectangular system. Okay, so please get your paper pencil ready. Okay, we have a rectangular system. You know, our last resort and the most reliable resort is always been just ARD, right? So in this case, we don't need to worry about, you know, we're drawing a perfect unit circle. It just goes straight to ARD. Okay. So with this setup, right, with our current setup, of course, I'm going to put it as think out aloud. Okay, this is something I would put down on the scratch paper before I actually write down the work, you know, in case I need to turn in or whatever. So it's just reflecting what I'm thinking about. So in this process, I need to understand that, okay, 3/5 is in the domain for arc cosine. Therefore, this piece is going to produce an angle, right? And this angle is going to be the input for sine. So we're expecting a ratio, right? The final result is going to be a ratio. Okay, so 3/5 is in the domain. And on the second thought, we also need to realize that in this process, right, it described that 3/5 is a ratio, and this ratio, we have arc cosine works on it, right? That ratio is indeed, right? That ratio is inside this ratio, which is 3/5, is in the domain of arc cosine. It produces an angle, and this angle is going to be between 0 to pi. Okay, between 0 to pi. Okay, and this angle is going to be the input for sine. Okay, and then finally it produces a ratio. So our final answer is going to be a ratio. Okay, and this ratio is going to be between -1 and +1. So we can anticipate our answer is going to be between -1 to +1. Okay, so this is what this expression describes. There are some other interesting details because this is a positive ratio, right? Positive ratio. We know that when we are handling arc cosine, we will, you know, chop off quadrant 3 and quadrant 4, and our angles, which are measured from standard position, right, counterclockwise from 0 to pi, and that's it. And the quadrant 3 and quadrant 4 are no-fly zone. So with that in mind, and this is a positive ratio, if the terminal end up in the second quadrant, it's going to be a negative ratio. So now we know the terminal must be, the terminal of this angle A is going to be in the first quadrant. It's going to be in the first quadrant. Okay. And because it's arc cosine, so the red is 3. So we get some ideas, don't we? We get some ideas already. Okay. And these numbers looks pretty familiar to us, right? So in this case, we can safely say it's going to be, because this is a cosine ratio, right? So this is a cosine ratio. So let's write it down. Let's write it down that we know, okay, we're still, you know, in the analysis. I will show you how to show the work later, okay? So we understand this is going to be an angle. Okay, this is going to be an angle. And of course, I can assume this equals theta, right? So let's make it theta, right? Let's make it theta, okay? Because theta is a common notation. It's a common notation. And we know that theta is going to be between 0 to pi. In particular, like we just showed, theta is actually going to be between 0 to pi over 2. It's going to be in the first quadrant. Okay, and most likely it's inside, not going to be, it cannot be 0, it cannot be 1, right? So theta is in the first quadrant. That's what we have seen, right? So not only it's inside of this terminal from 0 to pi, in particular, because the ratio is positive, therefore we know the terminal is going to be in the first quadrant, right? So this is the information we get by just looking at this piece and knowing arc cosines domain and range. And this also means that cosine theta is equals to 3/5. 3/5. And we know that the cosine's definition is x over r, right? This is definition is x over r. So we can draw the red, the red number, blue, the red, the blue, and etc., right? So we can tell that 3/5, which is x is 3, r is 5, right? So this is 3, right? And r is 5. R is 5. R is 5, right? So R is 5 somewhere here, right? So there we go. So we will have a blue piece. We will have a blue piece. Okay, we'll have a blue piece. Okay, so I want you guys to draw that picture as well. And I'm going to draw this picture using this software. So that way it's going to be, it's going to move with us. Okay. Okay, so that's a terminal. Wait, 3, 4. Wait, did I write? Sorry, 3, 4, my bad. 3, 4. Okay, so we're gonna have a piece of red and a piece of blue. The piece of red, the red piece, and the blue piece. So this is 3, and that's the blue, and there you go, right? So this is a 3, this is a 5, and needless to say, the blue is 4. They're all in the first quadrant. So this is pretty straightforward, right? It's a pretty straightforward case. So 3, 4, 5. And from what we have, right? From what we are given, then we got these. And what do we need? What do we need to find? Sine theta. Okay. What we are looking for is sine of this arc cosine 3/5. And that is theta, right? So we know cosine, we want to find sine theta. That's the question. And from the picture we drew, sine theta obviously is going to be what? It's 4/5. 4/5. So we already know the answer. Let's see how we show work. Okay, how do we show work? Okay, how to show work? When you're showing your work, you don't need to show all of these. Okay, I will tell you what to show, right? Suppose this is the question, right? So from that question, right? We know that's the question. So the first step, you're gonna assume, you're gonna say, okay, let that guy equals to theta. Okay, and then you draw this picture. Okay, then you say cosine theta is equals to 3/5. 3/5. Then you draw the picture and you mark some numbers on the picture. Okay, you mark some numbers on the picture to demonstrate that you understand what you're doing. We understand what you're doing, right? For example, we know this is 3. 3 is red, right? So this is going to be so I'm going to make these markings on the picture like I used to do, right? So this is the red piece, right? So this piece is 3. How come the 3 is so big? Oh, I should make it big. I'll make it smaller. Okay, let me make it smaller. Okay, so that's a 3. And I'm going to mark the R. So when you draw a picture, you want to draw it nicely. Okay. R is, of course, is 5, right? So we're gonna draw the 5 somewhere. We're gonna draw the 5 somewhere. So 5, right? The 5 and the blue is 4, of course, right? Academic questions, they're, you can see they're designed in such a way that you can easily, right? Just because we just want to know if you know how to, right? And so we try to make the number calculation numbers easier to work with. Okay, so this is going to be 3, right? The 4 is going to be there, right? So this is the blue number. You don't have to use so many colors. I use these colors because I want to make a connection with what we've done weeks past. Okay, the red is a horizontal, the blue is a vertical. Even though this is not on the unit circle, but it still has the same meaning. So once you draw this picture, and you get cosine theta equals 3/5, and the next thing you would write, you would just write, okay, sine of that is equals to sine of theta, and sine theta from that picture equals to 4/5. And you're done. You're done. So for this question, this is how much work you need to show. Nice and clean. Okay, you don't have to have the exactly same color as long as you understand. As long as you understand. Okay, I hope that helps. Okay, so let's look at the next homework question. The next, we have a bunch of homework questions. So I'm gonna do, we just did a sine, right? So let's do some, we just did this. Let's look at tangent, right? Tangent sounds interesting. Tangent of arc sine of -4/5. Okay, so here we go. I hope I remember that, right? Tangent of arc sine -4/5. 4/5. Did I copy the question right? Let me double check. Yes. Okay. So now, for this question, we understand that we want to find the exact value. We want to find the exact value. An arc sine, oh, by the way, I'm going to introduce an AKA notation, right? AKA notation in a lot of in your future text, you might not see arc sine. You probably will see sine. In sine, there's -1 to the power. But this should be read as arc sine. Okay, so these two are the same. Arc sine and this notation are the same. Okay, so they should be read as arc sine. Okay, so now, once again, think out aloud. Okay, in this question, we first need to understand, right? The input is a ratio. The input is a ratio. This ratio, arc sine takes ratio as input, produces angle, okay? Say theta. And the theta is going to be in the range of arc sine. The range of arc sine is negative pi over 2 to pi over 2. Okay, its domain, its ratio. We talk about that ratio, but not any ratio. The ratio has to be between -1 to +1. And certainly in our case, the ratio is equals to -4/5. So after we get this theta, right? So this piece is theta, and we take a tangent theta. We take tangent theta. Do you see that? Okay. So once again, if we look at the you know, from the perspective of definition, right? We have a rectangular system. Whoops. We have a rectangular system, right? We're gonna think of ARD. We're gonna think of ARD. Okay, take your time to draw that picture by yourself, right? Draw that picture, draw that picture. So now we have this picture, and we know that for arc, as far as arc sine goes, right? For arc sine goes, quadrant 2 and quadrant 3, this is a no flight zone. And the range for arc sine is either, it can be as low as a -pi/2, or from standard position to pi/2, not over quadrant 2 or quadrant 3, right? So with that in mind, right, we know that if terminal in the first quadrant, the ratio is going to be positive. If terminal is in the fourth quadrant, the ratio is going to be negative. And here we get a negative ratio. So the terminal is going to be where? It's going to be in the fourth quadrant. And we know it's -4/5. -4/5, right? And that's sine ratio. So it's going to be -4/5, something like that, right? So this basically tells us that the angle is in the, so this piece of information we get, right? Arc sine, if this is an angle, and this angle is going to be between -pi/2 to pi/2, in particular, because it's a negative ratio, so it's going to be between -pi/2 to 0. In particular, it's going to be inside. So it's in the fourth quadrant. It's in the fourth quadrant. From what we have learned, that's how much we can recognize. And what is more, we have sine theta, this theta is equals to -4/5, because that's the definition, right? That's the definition. We've done those, right? And this means that we know how is sine defined is y over r, right? So in this case, the y is -4 and the r is what? Is 5, right? So we have a triangle, right? And we can draw the triangle in the fourth quadrant now. We can draw the triangle in the fourth quadrant now. And we know that quadrant 2 and quadrant 3 are not in our consideration, okay, when arc sine is considered. So let's draw a couple of pictures. I want you guys to draw the picture along with me, okay? So we have, we know that it's y is, so this is a 3, -4, right? Because x is a positive on the fourth quadrant, right? So we get that. So we get the terminal, right? And we're also gonna get the red and blue. The red, right, is gonna be and the red and the blue. And that's the blue. There you go, right? And we're gonna make some marking because the second quadrant and third quadrant are not in our consideration, right? Because it's arc sine, right? Anyway, so here we're gonna make some marking. So something like that, right? I don't have to do this. It's probably fun to do it this time. Okay. Over here, so let's do for the fun of it, right? To see what happens. Okay, so on your picture, so you mark this down, and these lines we can mark them. We can mark them. So we're gonna mark them. Okay, red number. The red number we know it's going to be 3, right? We're going to use Pythagorean theorem because here we know the blue number. Blue number is -4, right? So -4 is a blue number. So I'm going to make it like 3, and that's going to be -2. The blue number is what we know first, because we know arc sine. Okay, and we know the r, right? We know r is 5, right? R is 5. Let's put it. Oh. Here. Okay. That's the R. Okay, that's a 5. So we mark these numbers. This is R, 5. I should bring that a little closer to the 5. So this way. 5, right? And then you can see this is 3, 4, 5 triangle, right? And the red is 3, positive 3. So 3, we're gonna mark it. So your picture, you're gonna draw a nice picture to show your work, to show your work. Okay. And we're gonna mark it as a red number. I hope that's clear to you, right? You can see it's a process. in this process, we get to review the domain range of these arc functions, And so here we go, right? Once we have this triangle constructed, we can find anything, sine, cosine, tangent, cotangent, secant, cosecant, right? So we're almost there. So from sine, theta equals -4/5, and we can find cosine theta, right? So what is the theta, right? So let's mark the theta. The theta, of course, is this angle theta, right? This angle theta. This angle measured clockwise. It's going to be hard for me to write theta because it doesn't show the angle. So I'm just going to show you here. This is a theta. Okay, that is theta. It's a negative angle because it's measured clockwise. Okay, so next, once we know this theta, we know cosine theta. Cosine theta is going to be the adjacent sides, which is 3/5. 3/5. So now let's see what we need to find. Okay, let's see now what we need to find. Right? So this is what we are up to. Right? From our assumption, this is going to be, this piece is going to be here. So tan of arc sine, that's theta. So we have tangent theta. So we need to find tangent theta. We know sine theta, we know cosine theta. As a result, tangent theta is just sine theta over cosine theta. Okay, so in the end, we just have to plug in the numbers. Sine theta is a -4/5. Cosine theta is 3/5. And the final answer is going to be -4/3. 4/3, we're done. Okay, how to show work? Once again, I'm going to show you how to show work, right? Because I was still showing you the think out aloud, right? It's like a scratch paper, right? To show work. You typically don't have to write so much when you show work, okay? The first thing you do, you mark, you introduce theta, okay? You can say let, okay? So for this question, you first copy the question. Okay, copy the question. Okay, so once you write this down, and then you will say, we already said it, right? So you write down here, right? You can say IE, and then you draw the picture. You draw the picture underneath, and you have cosine theta, which is shown over there, 3/5. And the last piece you need to show, you just show this piece. Okay, that's all you need to show. That's all you need to show. Let me make it smaller so you can see the whole of it, right? So for showing work for this particular question, right? So let me make it a little more compact. This is how much work you need to show, okay? Having a proper picture really shows the reader how well you understand the question, So that's very, very important. That's very, very important. Okay. So this is you can see we constantly thinking about the domain and range for those arc functions. Okay, let's try a few more. Okay. Let's choose another question. We have done the first one. We have done the second one. And Let's do an arctangent. How about that? How about we do an arc? We have done arc cosine, arc sine. Let's do an arctangent, right? So we have sine of arctangent of -12/5. Okay, -12/5. So we're gonna go back to our other page. Okay, so this is the other question. So we want to find the exact value for arctan of -12/5. So that's the question. Okay, make the fonts a bit larger. Here we go. We want to express the exact value. Okay, we want to express the exact value. Now, we have an arctangent. Okay, if we think out loud, right? If we think out loud, we know that this piece is going to be an angle. So this is going to be an angle. Okay, and this angle has to be in the range of arctangent. What's the range of arctangent? It's -π/2 to π/2, right? Remember we talked about those things, right? So now it's apply, it's application. So let's draw the picture. Let's draw the picture. I'm going to set up the rectangular system, right? I anticipate this triangle is not special, and it looks like we're going to have some, quite interesting, well, it's just a 5, 12, 13 triangle, right? So we have these triangles set up. Here we go. When arctangent is constructed, so let me remove some of these numbers. Okay, they're pretty annoying. Too many of them. There we go. This is easier. All right. So we understand that under this assumption, tangent theta is equals to -12/5. Right? So we were basically told y/x. Right? y/x. That's a definition of tangent. So you can see it either as, because it's in the fourth quadrant, right? It's either in the first or the fourth. It cannot be in the first quadrant. Okay, in this case, and of course we have -12, which is a y, right? And this is 5. I'm worried that you may not see the negative sign. See, do you see it now? Yes, right? So -12/5, -12/5, the fourth quadrant. And in particular, we actually know the theta is between -π/2 to 0, right? Because we know so well about the range of arctangent, right? Arctangent domain is all real numbers. The range is between -π/2 to π/2, right? The domain for arctangent is all real numbers, okay? From -∞ to +∞. Any ratio will do. Any ratio will do. And that will be the input for arctan. Okay, so let me just write it down there. It produces angle. Angle are going to be in -π/2 to +π/2. Okay, and quadrant 3 and quadrant 2 are crossed out. They're crossed out, right? So with that understanding, we can draw the picture now. We can draw the picture now, right? So -12/5, right? y/x. So we can draw that picture now. So the terminal That's a terminal, right? That's a terminal because that's y over x, right? And we can also draw the red line and the blue line, right? So 0, 0, 5, 0, that's going to be the red. And the blue, wait. The blue is 5, 0, 5, negative 12. So that's going to be the blue. Let me show it to me. There you go. And we can mark the numbers. We certainly can. Okay, so we're marking the numbers. So we have, and this is 5. Right, because we know the red and blue already. So 5 is the red, right? 0.05 and the red number. Okay, and the blue number, which is negative 12. So that's negative 5, the blue number. And of course, the hypotenuse is 13. Hypotenuse 13, right? So we now get everything pretty much, right? And the angle is, this is theta. This is theta. Okay. And these two quadrants, quadrant 3 and quadrant 2, they're gone. So we're almost there. And next, we just have to find sine theta. So here we need sine theta, right? So finally, that equals to sine of theta. Or what is sine theta after we get everything, right? And sine theta is going to be y over r, which is negative 12 over 13. Okay, so that's the answer to this question. In terms of showing work, show work, right? Show work. You just, it's all here. It's all here. Okay. And you don't really need this piece. You don't really need that piece. Okay. And the last thing I would do to make the picture perfect is that I'm going to mark this 13 on the hypotenuse, which is going to be, let's see, 2, negative 5. Okay, so I'm just going to mark that number for the reader. There we go, right? So these are the examples for our homework questions. And these, to know how to do these exercises, how to do these questions is very important. You'll need them in your calculus classes, okay? Or, you know, you also need it for pre-calculus class and the current class you're taking right now. But anyway, that's long enough. Thank you for watching. Until next time.